So good evening, guys. In the last session, we discussed about what kind of application we can develop using Java. So let's revise for the previous class. Like what is Java? We'll see that Java is a computer programming language developed by Sun Microsystem in 1991, and initially its name was Oak Programming Language. And later on, its name was changed to Java. James Gosling is the lead for the team who developed Java language. Next, we saw that the first version of Java came in market in 1995, and Oracle Corporation has currently acquired the Sun Microsystem. Now Java is under the license of Oracle Corporation. Next, we saw that what kind of applications we can develop using Java. Like we can develop a standalone application which can run on in one machine, example like calculator, notepad. Next, we can develop a web application and everybody can access the web application using internet. Example is like Gmail, YouTube, Facebook. And next, we can develop mobile application like WhatsApp, Messenger, PhonePe, etc. After that, we are trying to understand what are the features of Java. Yesterday, we discussed that Java is a simple, platform independent, secure, and multi-threading. So today we will discuss more about the features of the Java. We'll discuss in details about the features of Java. So let's see. The first feature is Java is simple. Why we are saying Java is a simple? Can anybody tell? Okay. We are saying Java is simple because the complex topics of C and C++ are eliminated from Java. We are saying it's simple. Complex topics of C++ are eliminated Java. Example like operator overloading, pointers, memory management. So these topics are confusing to the people. So those complex topics are eliminated from Java language, and that is the reason people are saying Java is a simple programming language. And the most important feature of Java is platform independent. Next here, which is the most important feature we can say because Java is a platform independent. Like what is the meaning of platform independent? We can say like Java programs can be executed on any machine. Uh, Java programs can be executed on any machine. Now, how Java programs can be executed on any machine? Like why C program cannot be executed on any machine? What is the reason behind? Like what is the reason behind? Can you tell me the execution flow of C language? Let's understand why C is not a platform independent and Java is a platform independent. Let's suppose we have here C language. C language. Once we compile C programming language, generates object code. For compiling, it will generate let's say, object code. Here we are compiling it. Now assume that we are going to write a C program, and so can we execute C program directly in a computer? No. Why he cannot execute C program directly in a computer? The computers cannot understand C language. So then what we need to do? What we need to do? We need to translate that. So since computers cannot understand our C programs, then we need to translate that C programming language, which is going to generate an object code. That's what we are doing here. C language after compiling it is generating an object code. The process of converting C programming to object code is known as compilation. The process of converting C programming to object code is called as compilation. So once the program is compiled, then we need to run the program. So compilation is required, then execution is required. And whenever we are going to execute the program, it will give an output. So in order to provide output, whatever the object code is available, this object code is converted to machine understandable format. execution, we will get an output. The output. For example, if you use Windows operating system, then this object code will be converted to Windows understandable format. And if you execute this object code in Linux machine, then this object code will be converted into Linux understandable format. So whenever we do this compilation, whatever the code is available, this code will be compiled in the machine understandable format. Okay. So suppose if I want to run the same C program, I need to compile that in every machine, and then only we can run that. So if you compile the C program in Windows machine, it will run only in the Windows. And if you compile the C program in Linux machine, then it will run only in the Linux machine. Uh, but when it comes to Java, that is not the process. There we are going to write a Java program. Like whenever we are going to write a Java program, can we run it directly? No. There also we need to first compile and execute it, convert the Java program into bytecode. So let's see that. Java programming. After compiling, generate bytecode. So now when we compile the Java program, it is not going to give output directly. In the case of C program, we used to convert into object code and get the output. Whereas in Java program, we are going to generate an intermediate code, and that intermediate is called as bytecode. So this bytecode is human understandable or bytecode is machine understandable. So humans cannot understand bytecode, and machine will understand only binary language. So here Java program is converted into bytecode. Now I need to run this Java program. Uh, Whenever we run this Java program, one machine will start, that is JVM, Java Virtual Machine. So this is the reason why Java is platform independent. JVM. What we got here, like the Java program is converted into bytecode after compiling. Next, this bytecode is running and will start the Java virtual machine. So this is the reason why Java is platform independent. And Java program is available and we are going to compile the Java program. When we compile the Java program, bytecode is generated and that bytecode we are going to execute. So when we execute this C program directly, it gives the output. Whenever you execute the Java program, JVM is going to start first, and the JVM stands for Java Virtual Machine. JVM is the most important part in Java. For every Java programmer will execute with the help of JVM only. Next question arises like, can we see the JVM? No, we cannot see. It is virtual. Virtual means we cannot see with our eyes. Like when you run the program, it will start internally. So we cannot see with our eyes, but it will run our program. So now whenever you execute the Java program, JVM will start. So here our JVM is intelligent. Let's right executing. So now whenever you execute the Java program, JVM will start. And here our JVM is intelligent because it will not execute the program directly, which was in case of C language. Directly we used to get the output. JVM will not execute the program directly. JVM will check first where you are executing, like the program, in which machine you are executing, in which machine you are executing the program. Is the machine a Windows operating system? Is machine the Linux operating system? Is machine the Mac operating system? First, it will check all those. At the different machines, different platforms. Because let's see, this is Windows. This is Linux. This is Mac. So first of all, what JVM is going to do, it will check the machine. Like, is it a Linux machine? Is it a Windows or is it a Mac? What kind of operating system is there? First, it is going to identify that. So once our JVM will recognize that where we are running our program, this JVM will convert our program into machine understandable format. So that means, can I run my Java program in any machine? Actually, I am running the Java program, or I am asking the JVM to run the Java program. what I'm here doing, we are not running the Java program. We are just telling to JVM, please run my program. So then that JVM is going to take the bytecode, will take the bytecode, and it will convert the bytecode into underlying machine understandable language. Means if you are using Windows machine, your laptop is having Windows OS, then that bytecode will be converted into Windows machine understandable format. Same Java program can I run in Linux also? So that is the question. So, or do I need to make any changes? No, no changes are required because this bytecode is not dependent on Windows, not dependent on Linux, and not dependent on either Mac OS. So here we can say that bytecode is one intermediate format. Yes, intermediate format. And I am a programmer, so I have written a Java program and I compiled my Java program. So when I compile my Java program, that compilation is generating a bytecode for me, and that bytecode that you cannot understand. So I cannot also understand, and computer can also not understand this bytecode. So what happens like then that bytecode we need to execute, and when we execute that bytecode, JVM will start. So now the question arises how we will get JVM. Like where is JVM? And so let me tell. Uh, if you install a Java software, then JVM will come automatically. Like how JVM will come to my machine? If you install the Java software, then JVM will be installed by default. Like if I need to develop a Java program, I need to install Java program first. So Java is free and or Java is licensed. You can say like Java is a free language because we can download and install it. You can download and install the Java. So when you install Java, JVM will come automatically. And whenever you run the program, JVM will start automatically. Like what is the role of JVM? JVM will convert bytecode into machine understandable format. Here we have the bytecode and JVM will convert either it is suppose it recognizes that it is Windows, it will convert it into Windows uh, like to execute on the Windows. Now tell me, C is a platform dependent or independent? A platform dependent, whereas Java is platform independent. How Java became platform independent? Because of JVM. So if JVM is not available again, it will become platform dependent. So we can say that at the time in the year of 1991, Sun Microsystem identified the problem. So computers are understanding only machine language. So whenever you develop a program or you develop an application, that application should be executed in any machine. So like now, whenever we run the program, so JVM will take our bytecode and it is going to convert the bytecode into computer understandable format. When when it understands which is understood by the computer, so what it will do, it will provide the output. So this is the execution flow of Java program. Like Java program gets compiled, converts into bytecodes get executed by JVM, and after that it gets converted into computer understandable format. So like whenever we write a Java program, the file extension will be .java. but it will be dot Java. And whenever we compile the Java program, the extension will be after compilation, it will be dot class. Program will be saved in dot Java, and after compiling, it will be converted into dot class. So, what are the points in platform independent? Like Java programs can be executed on any machine. JVM made Java as a platform dependent. JVM stands for Java Virtual Java Virtual Machine. We can say JVM is responsible to run or execute Java programming. Are you guys clear? Okay. Next important feature we can say Java is robust. Java is robust. What is the meaning of robust? Robust means strong. So why we are saying Java is strong? The reason of saying Java is robust, there are two reasons, not one reason, because two reasons Java is called as robust. First one is automatic memory management. Where in order to run the Java program, how much memory is required? In order to run the Java program, how much memory is required? That I no need to specify that. JVM is intelligent. JVM will allocate the memory which is required to execute the program. So when we go for C language, we need to specify how much memory is required to run the program. We need to clean up the memory after the execution is completed. So that is the most headache for the programmers. Like how much memory I need to allocate, uh, when I need to deallocate memory. That is the most challenging part. But when it comes to Java, do I need to bother about memory management? Who will take care of memory management? JVM. So this because of this automatic memory management, we can say Java is robust. Next, we can say exception handling. There is a mechanism called exception handling in Java. So Java people are calling robust because of two reasons: automatic memory management and exception handling. So whenever you write a program, if any exception occurs in the execution, we can handle that in Java. So Java is having exception handling capacity. Like automatic memory management is there in Java, and that's why Java is known as robust programming language. Next one we can say OOPS. Next feature, OOPS, object-oriented programming system. Java is a object-oriented language. Now this is not the right time to talk about OOPS. Like after 2 weeks, we can discuss about it. Once we are comfortable with the basic of Java, then only we will enter in OOPS. In OOPS, we can say what, like everything will be represented in object format. Next, we can say code reusability. Code, re, code reusability. Whatever the code we will write in, we can reuse for different purpose. Was if you follow OOPS principle, OOPS is nothing but a set of principle available. Like in your academics, you might have studied like inheritance, polymorphism, abstraction, encapsulation. These 4 points are there. So Java supporting or those 4 principles. That's why Java is called as object-oriented programming language. Java supports OOPS. That's why Java is called as object-oriented programming language. So what is the advantage? If Java is supporting OOPS, what is the benefit I am going to get? Yes or no? So here benefit for you is code reusability. We can reuse our code. If I write one code, the same code I can reuse for another purpose. Code reusability we can achieve by using OOPS concepts. We are going to spend almost 2 weeks. Uh, like what is OOPS and how we are going to use OOPS. Within 2 minutes of time, I cannot give you knowledge of OOPS. So we will study in detail on in future. Hmm. And next one we can consider another feature of Java. People say Java is secure. Like virus cannot affect the Java program. Secure. Like whenever you go for C language, it is not secure. Why? Because the object code which is generated, virus can affect that object code. Antivirus software we are going to install to secure our system. So whenever you compile your C program, object code is there and virus can affect the object code. Whereas whenever we compile Java, we get bytecode. That bytecode generated virus cannot attack that, and our Java program is secure by default. So Java programs are secure by default. Next one we can say is like distributed. Distributed. So what does that mean? Java is distributed language. What is the meaning of distributed language? Now assume that I am writing some lines of code. I am writing 10 lines of code. In Java, you no need to execute these lines in sequential order. After one is completed, go for two. After two is completed, go for three. In sequential order, you no need to execute. Now suppose we have 10 line of code. Let's assume first 3 line of code is to deposit money in your account. Next 3 lines of code is to transfer from account to another account. Next 3 lines are written for like checking the balance and download the statement. So in my Java project, there are several functionalities available, and I am writing the programs with different functionalities. So do I need to execute one after another? No, I can execute them parallelly. Suppose I need to check my balance, I can check it. So that's why we can say, since we can execute it in parallel, that's why Java is known as distributed execution. So that's it for the today's class. Like today we have seen the features of Java. In next class we will continue with some more features of Java and we will see what is the difference between JDK, JRE and how we can install Java. All those we will see in the next class. Thanks everybody. Anyone has any question? You can unmute yourself and ask.